Hello everyone, I am Pallavi Dholakiya from Smt.R.S.Kalaria Primary School. Welcome to YouTube channel. Today we will learn chapter number 5, Understanding Elementary Shapes of Standard 6 Maths. In previous video we have learned all the concepts of the chapter. Today we will see exercise of the chapter. So let's start. Exercise 5.1, question number 1. What is the disadvantage in comparing line segments by mere observation? So here is the answer. If we compare line segments merely by observation, we might make error in correctly judging the length of the segments. It may happen sometimes our observation may be wrong. Also, we can just compare the length but not estimate exact length of the line segment. Here only we can judge, but exact measure of the line segment we cannot say. Question number 2. Why it is better to use a divider than a ruler while measuring the length of line segments? It's better to use a divider than a ruler while measuring the length of the line segment because we get exact reading. By using divider, we will get the exact measure or a reading of the particular line segment, and chances of error does not occur. So less chances of error are there. Let us see question number 3. Draw any line segment, say AB line segment. Take any C point lying in between A and B. Measure the lengths of AB segment, BC segment and AC segment. Is AB equals AC plus CB? Now here one note is given that we have to consider. Note, if ABC are any 3 points on a line such that AC equals CB, AC plus CB equals AB, then we can be sure that C lies between A and B. By considering this note, we will have the sum. Very first we will draw one line segment A and B. If we take midpoint C, then A to C equals 2 cm and C to B equals 4 cm. Now AB equals 6 cm, AC 2 cm, CB 4 cm. Therefore, if I want to measure whole AB equals AC plus CB. 2 cm plus 4 cm equals 6 cm. Question number 4. If ABC are 3 points on a line such that AB equals 5 cm, BC equals 3 cm and AC equals 8 cm, which one of them lies between other two? Let us see. Here measure is given to us. AB equals 5, BC equals 3. So very first we will draw AB. It's 5 cm, then BC is 3 cm. So AB plus BC will be AC, that is 5 plus 3, 8 cm. Now 5 cm plus 3 cm, 8 cm, which is as same as AC. Therefore we can say B lies between A and C. Question number 5. Verify whether D is the midpoint of AG segment. Now here figure is given to us and we have to verify that G is in the middle of the D is in the middle of the A and G. Now if we observe this segment, we can say that AG is having total 6 units, AD is having 3 units and BG is having 3 units. Now AG equals AD plus DG. Now we have to know that this point is a midpoint. So if we see AD, it is having 3 units, that is AB, BC and AC. Same way other side also, DE, DF and DG. 3 units they have. So AG equals 6 units. 3 units this side and 3 units other side. So both the sides it is having AB equals BC. So what is the measure of AB? Will be same measure of BC. Now C is the midpoint of BD. Now again we'll move further by having one more point, that is BD. Here C is the midpoint. So BC is the same as CD. Since AB equals BC, same way BC equals CD. Hence we can say AB equals CD. Now let us see exercise 5.2. Question number 1. What fraction of clockwise revolution does the arc hand of a clock turn through when it goes from? Now here we will draw one clock. This is the clock. Now let us see, first question is 3 to 9. Now it is at 3, it is going to 9. So what revolution it has taken? Half. So we can say half revolution. Same way B, 4 to 7. Now our hand is at 4 and it is going to 7. It's 4, here it is there, and now it is moving to 7. So it's only 1/4 of the revolution. Okay. Now others you can do by your own. B. Question number 2. Where will the hand of the clock stop if it starts at 12 and makes half revolution clockwise? Now very first, what is clockwise? Clock turns from 12 to 1, 2, 3, 4, 5, 6 and so on. So it is called clockwise. When it goes reverse, means 12, 11, 10, 9, 8 and so on, it is known as anti-clockwise. Here we have to consider for clockwise. It is at 12 and it is start revolving to half revolution. Now it is at 12, so this hand will come to 6 when it takes half revolution. So answer of this question will be at 6. Now question number B, starts at 2 and making half revolution. Now hand is on 2 and it is making half of the revolution. So once it's moved clockwise, it will be at 8. So here we can say it must be at 8. Question number 3. Which direction will you face if you start facing? Now we have to consider the directions. So it is here west, east, north and south. First, if you are at east and making half revolution, now you are at east making half revolution, so you will be at west. So answer will be west direction. Same way we will see D, west and making 3/4 of revolution anti-clockwise. Now you are at west. Clockwise means this way. Here we have to see anti-clockwise, and it is making 3/4 of revolution. So from here we will start and go in opposite direction. You will be at north direction. So answer is north. Now question number 4. What part of revolution have you turned through? If you facing east and turn clockwise to face north. Now you are at east and turning 3/4 turn and turning clockwise to north. You are at east turning clockwise to So it is 3/4 of the term. It is more than half. More than half means 3/4. Now next is C. You are at west. So again our starting point will be west and turning clockwise to east. Clockwise means this way. So you will be at east. So the revolution is half. So here we can say half revolution is done. Question number 5. Find the number of right angles turned through by our hand of the clock when it goes from. Now again we will focus on clock. Here we are having clock. So very first 3 to 6. Hand is on 3 and 6. So how many right angle? Only 1. So we can say 1 right angle. Second 2 to 8. Okay, let us see 2 to 8. So here 1 right angle is formed and this is second right angle. So 2 right angles can be formed. C. 5 to 11. Now 5 to 11. Between this 8 is there. So again 2 right angles can be formed. This is first, this is second. So we can say 2 right angles. Same way 12 to 9. Question number E. Let us see how many right angles. One hand is on 12 and 9. Let us see. It's 1 first right angle. Then it will be at 6. Second right angle. Again it will be here. So 3 total. 3 right angles can be formed. So here we can say 3. Now let us see question number 6. How many right angles do you make if you start facing? Yeah, we are at south and turning to west. So how many right angles we will see? South to west. 1 right angle. So we can say 1. North and turn anti-clockwise. Here we are at north, turning anti-clockwise to east. So north to east. 1 right angle. This is second and this is third. So we can say 3 right angles. West to turn west. You are at west and again you want to be at west. So west to north 1, north to east 1, east to south 1 and south to west. So total we can say 4 right angles can be formed. Question number 7. Where will our hand of a clock stop if it starts from 6 and turn 1 right angle? Again clock. It is at 6 and turning 1 right angle means it will be at 9. So answer is 9. Second, it is at from 8 and turns through 2. Okay, now we will see it is at 8 and turning to 2. So 1 right angle, again it will come to here. So 2 right angles can be formed. So total 2 right angles we can say. Now let us see exercise 5.3. Question number 1. Match the following. 2 columns are given. We have to match right options. First is straight angle. So straight angle we can say half of the revolution. So I can write 1 for C. Second it is right angle on 1/4 revolution we can say classify each one of the following as a right, straight, acute and obtuse angle. Here different angles are given. So very first, this angle A, this is acute angle. It is less than 90 degree. So acute. Second one is greater than 90 degree. So it is obtuse. Let us see third one, C part. This angle is a right angle. So we can say right. E1. Let us see D. Here this figure is given to you, and this you have to measure. So this is more than 180 is called reflex angle. Now next is E. Here you are given this figure and you have to measure this. So this is called straight angle. And last, you are given M shape, and this angle you have to decide which is less than 90 degree. So it is acute angle. Now let us start exercise 5.4. Question number 1. What is the measure of right angle? Now we all know measure of right angle is 90 degree. B. What is the measure of a straight angle? Straight angle means 180 degree. Question number 2. Say true or false. First, the measure of an acute angle is less than 90 degree. So this statement is true. Second, the measure of obtuse angle is less than 90 degree. So this statement is false because it is more than 90 degree. The measure of reflex angle is greater than 180 degree, which is true. B. The measure of one complete revolution is 360 degree. This statement is also true. Now let us see question number 3. Write down the measure of some acute angles. So acute angle means angles which are less than 90 degree. So we have to write any 3 measure. We will write say 38 degree, 65 degree, 49 degree, 45 degree and so on. Which will be less than 90. You can write any under 90. Next is some obtuse angles. Now obtuse means greater than 90 degree. So greater than 90 degree, 105, 125, 143 degree and so on. You can write any of the measure which is greater than 90 degree. Now question number 5. We will see first question number 4. Measure the angles given below using protractor and write down the measure. Now first angle given to you is this. Now how to measure the angle? Very first you have to keep your protractor on an angle like this on a vertex. From where the line passes, that point you have to note down. Here it is between 40 and 50. So it is 45 degree. Same way, B. You are given this angle. So how to measure? Very first we will keep our protractor on the vertex. And from where the line passes, that we will observe. It passes through 120. So measure of angle is 120 degree. So this is how we have to measure the angle. Now let us see question number 5. Which angle has large measure? First estimate and then A angle should be 30 degree. Now let us measure. We'll keep protected on the vertex and we will measure. The line passes through 40. So measure of angle A is 40. We have estimated 30 degree. Now same the measure of B. First we will estimate. It will be of 55 degree. Now let us measure. We'll keep on the vertex. It passes through. It passes between 70 to 60. So the measure of this angle is 65 degree. Now let us see question number 7. Fill in the blanks with acute, obtuse, right or straight. First, an angle whose measure is less than right angle is acute. We know the measure of acute angle is smaller than 90 degree. An angle whose measure is greater than right angle is obtuse angle. We know that angle is known as obtuse. An angle whose measure is sum of measure of two right angle is, now two right angle means 90 plus 90, 180. 180 is a straight angle. Number D. When the sum of the measure of two right angles is one of the right angle, then each one of them is acute angle. When sum of the measure of two angle is that of a straight angle, but if it is one of them is acute, then other should be obtuse. Now let us see question number 9. Find the angles between the hands of the clock in each of the figure. Now here figure is given to you. Here we have to see the measure. Now by observing this, we can say it is a 90 degree. That is right angle. But we will measure it through protractor like this. So this line goes to 90 degree. So measure of this is 90 degree. Same way 6 o'clock. Now 6 o'clock is a 180 degree. We know that it is a straight angle. So here by putting this way, we can see 180 over here. So 180 degree is the angle for 6 p.m. Question number 10. Investigate. In the given figure, the angle measures 30 degree. Look at the same figure through magnifying glass. Does the angle becomes larger? Does the size of angle change? Okay. Now here is the 30 degree angle and we can say that entire image will look larger when we put magnifying glass on the image. So it looks large, but the measure or the size of the angle does not change. It will remain same. Now let us see exercise 5.5. Question number 1. Which of the following are models for perpendicular lines? Now here we have to say that perpendicular line can be all possible or not. First, adjacent edges of tabletop. Now we know how it is. Tabletop is always perpendicular to each other. So we have to say yes. The lines on the railway track. Now railway track lines never be perpendicular. It is always parallel. So here for question 1 we will write yes. Here for railway tracks no, because they are always parallel to each other. It is not perpendicular. Then the line segments forming letter L. In letter L also two lines are perpendicular, so we can say yes. The letter V, as this is a stunt line, so it is not perpendicular, so we can say no. Let us see question number 2. Let PQ line segment be perpendicular to line segment answers we have to solve. Is CE equals EG? Now here you are given line. Let us draw it. 0, 1, 2, 3, 4, 5, 6, 7, and 8. It is A, B, C, D, E, F, G, and H. It intersects at point E. This line is M. This is L. Now, is CG equals EG? Again, CG and EG is equal? Yes, because CE and EG is having two units. CD, DE. Same way, DF, FG. So, here we can say is equal. So, CE equals EG equals 2 units. You can say like this. Second, does PE bisect CG? Now PE means this line. PE bisects CG. Yes, this bisects at point E. So here we can say yes, bisects at point E. Question number D. Are these statements true? AC is greater than FG. So A and C is greater than FG. It is having 2 units. It is having only one FG. Here AB and BC. So we can say yes, true. 2 is greater than 1. Same way, CD equals GH. CD, GH. Both of them is having 1 unit. So you can say true. 1 is equal to 1. Third, DC is less than EH. Now DC is having 1 point. EH is having 1 and 2 points. So this statement is also true. We can say 1 is less than 3. Now let us see exercise 5.6. Question number 1. A. Triangle. Name the types of following triangles. A. Triangle with length of sides 7, 8 and 9 centimeter. Here all the sides are different, so it is scalene. We can say it is scalene triangle. B. Triangle ABC equals AB equals 8.7, AC equals 7 and BC also 6. So again, a measure of the triangle is different for all the sides. So again it is scalene. Next, triangle ABC, triangle PQR such that PQ equals QR equals PR equals 5 centimeter. Now here, each side is of 5 centimeter. So a triangle which is having all equal sides is known as bilateral triangle. B. Triangle DEF with measure of 90 degrees. So here we can say right angled triangle. Rest of all you can solve by using your own logic. Question number 2. Match the following. Here measure of triangle is given and type of triangle is given on the other side. First, 3 sides of equal length. We know equal length means it is equilateral. So for 1 it is E. Second, 2 sides of equal length, that is Third one, all sides are of different length. Different length, scalene, A option. Next, three acute angles. So it is acute angle triangle. So it is F. Same way, one right angle. So it's option B, right angle. One obtuse, that is option C, obtuse angle. Last, one right with two equal sides, that is isosceles right angled triangle, and option is B. Now, question number 3. Name each of the following triangles in two different ways. You may judge the nature of the angle by observation. So here, different triangles are given to you, and we have to measure. We have to see the measure, and we have to decide the type of triangle. Very first, one side 8 cm and other two side is of 5 cm. So here we can say two equal sides, that is isosceles, and again it is acute angle. Acute angle triangle. Measure of angle is less than 90 degrees. Second one, 17, 15 and 8 degree. All the sides are different. So here we can say it is scalene. And here it is right angle is formed. So right angle triangle. The type of triangles. Let us see exercise 5.7. Question number 1. Say true or false. A. Each of the angle in a right angle is a right angle. Now, rectangle is having right angle inside it. So, this statement is true. B. The opposite side of rectangle are equal in length. So that is correct. In rectangle, opposite sides are equal. Let us see F1. All opposite sides of trapezium are parallel. This is false. It is not parallel. Question number 2. Give reason for the following. First, a square can be thought of as a special rectangle. Now, if we observe, we can say because it fulfills all the properties of rectangle, all its angles are right angle and opposite sides are equal. So, a square can be thought of as a special rectangle. C. A square can be thought of special rhombus. Because all the angles are of 90 degrees, that is right angle, and has all its sides equal in a rhombus. So we can say square can be thought of as a special rhombus. Question number 3. A figure is said to be regular if its sides are equal in length, angles are equal in measure. Can you identify the regular quadrilateral? So here we can say yes. The regular quadrilateral would be a square because all the sides are equal in length, and length as well as angles are equal in measure in the square. Exercise 5.8. Question number 1. Examine whether the following are polygons. If anyone among them is not, say why. Very first, it is open figure. You are given a figure, it is open figure, so it is not a quadrilateral. Here we will write no, it is not a quadrilateral, it is open. That's why it is not quadrilateral. That is, it is not a polygon. B. Now it is closed figure, so it is a polygon. So here we can say It is curve in shape. So it is not a polygon. Now question number 2. Name each of the polygon. First given to you is four-sided. So it is quadrilateral made up of 9 segments. Second, it is triangle. We can say it is triangle. Third, it is 5-sided. So it's pentagon. And fourth one is having 8 sides, which is octagon. Question number 3. Draw a rough sketch of regular hexagon connecting any 3 points of its vertices. Draw a triangle. Identify the type of the triangle we have drawn. Now here, very first, this is a regular hexagon, and by joining any 3 points. So here I have joined A, E and C. Can join and have a triangle. So this triangle is a equilateral. All the sides of this is the same. So equilateral triangle can be formed. Question number 4. Draw a rough sketch of regular octagon. Draw a rectangle by joining exactly 4 of the vertices of the octagon. So here, this is the octagon. We can say A, B, C, D, E, F, G, H. Now by joining any 4 vertices of it, so I have joined A, B, E, F. So here rectangle is formed. I can also join H, C or G, D. Then also rectangle can be formed. Let us see exercise 5.9. Match the following. Here, one side name of the shapes are given, other side shapes are given. We have to match according to its name. Cone. Here one is this shape, so answer is B. Sphere. Sphere is this. So here fourth option, cylinder. Last option, option number 5. Cuboid is this. Pyramid. So this is the shape of triangular pyramid. Now question is, give to new example of inch. So cone we can say funnel and vertical. For sphere we can say block or bowling ball. Cylinder we can say cylinder, maybe in a tube light and iron rod. Next is cuboid. We can get many examples of this, book, jewelry box, compass box, etc. Pyramid. Pyramid shape is block toys and diamond. Question number 2. What shape is A? Your instrument box. We are having our geometry box. It is of cuboid. So here we will say cuboid. Next is a brick. Brick is also cuboid. So you will say it's cuboid shape. C. A matchbox. Again, matchbox is a cuboid. So we will say it is cuboid shape. D. A road roller. Road roller is rounded. So it is near to cylinder. So we can say cylinder. Next. A sweet ladle. It's of sphere shape. So we can say sphere. Students, I have completed all the exercises of this chapter. I hope you are clear. Thank you.